Okay. I will share now the screen. And I want to discuss the answers so that even for people that were not answering, to see what are the correct answers there. Okay. Just 1 second. Okay. Okay, so now you should be able to see my screen. So what is to CCNP? What is RC4 to TKIP?
Yes.
Yes. Why is that?
It's the new encryption algorithm.
Yes.
So RC4.
Yes. So RC4 was used in WPA. Remember, for in web, sorry. Okay, for encryption. Okay. So in CCNP, when we talked about WPA2, that I did not open here, I think. Let me take it from here. Should be this one, I think. Yes. Okay. So when we're talking about WPA2, we talk about AES. Okay, AES that is used in WPA2 for encryption. Okay, so this is why here it's correct. What is not working the net anymore? AES is for CCNP. What is RC4 to TKIP? Okay, perfect. Web uses cipher, while WPA2 or CCNP uses a cipher. Perfect. The stream cipher and the block cipher. And this is again something that I expect you to know. What is a stream cipher? What is a block cipher? Okay, so RC4, it is a stream cipher. And CCNP uses AES, and AES is a block cipher. CCNP is authenticate,
then encrypt.
then encrypt. And why is that? Because if we look at the CCNP, yes, here, what we first do, we first compute the MIC, and the MIC is the one that gives us the authentication, the integrity, and then we encrypt both the data and the MIC. So first we compute the MIC, then we encrypt. So it's authenticate, then encrypt. Okay, or if you watch here, first we compute the MIC, then we concatenate to the message, and then we encrypt. Okay. What is used to provide confidentiality? What is used to provide integrity?
Encryption is used to provide confidentiality.
Yes.
And the MIC?
Yes, to provide integrity. Here it's accepted. There are accepted even others. You can put MAC, message authentication code, MIC, message integrity code. I tried to put more possibilities. If you wrote something similar and they didn't take it, you can let me know. So I put all the as many as possible correct answers here. Okay, and cracks attacks. The cracks attacks is against the
four-way handshake.
The four-way handshake. Okay, and you could have written as four-way handshake, or you can put just four-way handshake, and everything should be fine. Okay. Great. So the people that answered, Bogdan, Stefan, Vlad, Radu, Raresh, and Laura. You were all granted one point in the activity, so you should see there. And now I have another one for you. It's similar. So again, the first 5 to finish. Let me know. It's now visible. This is with some questions that you just need to put true or false. So let's say it's easier than the previous one. So one correct answer by now, Bogdan.
Should we retry? Because if we retry, we will always do it right.
Sorry, it's showing the solution.
Yes.
Okay, so it's one of my. So you should not retry. So basically, it should be just from the first attempt. I probably put the settings bad. It should not show the solution.
Okay.
Okay, so do not retry. If it didn't work, it didn't work. In this way, we even finish faster, and then we have more time to discuss other things. But you did it from the first, I think.
If you're referring to me, I didn't. It wasn't my first try.
Ah, no, you didn't, and even others did it. Okay, so for this one, sorry, my fault. There will not be any points, so we can just discuss it directly. So I bring it here. Let's discuss it. RSN does not accept web. Is this true or this is false? RSN, I remember, is the robust are the robust networks that we can find here in WPA2. This is the RSN. And the question was if RSN accepts or not web.
It does because it accepts TKIP.
It accepts TKIP, but TKIP should be WPA. It has these, let's say, two flavors, AS or TKIP, but it also accepts web as it was at the beginning because of backwards compatibility. I didn't put it here because usually these two are the main, let's say, usage of RSN. But it is backwards compatible completely. So it can also accept the web. Okay, so this is false. Okay, it is accepting the web. 802.1x authenticates the device, not the user. This is true or this is false?
It's
It is false.
It is false. Why it's not authenticating the device, but it's authenticating the user?
Because a user might try to connect from a different device.
Yes.
In any case, I think it's by design.
Yes. So what we were using, right, were these credentials that we have on this authentication server. So it's not based on the MAC address. It is used afterwards to derive a key and so on, but it's not used in the authentication. Okay, so I'm not authenticating the device. I'm authenticating somebody that has some credentials that are stored on a server. So that it's the user. Okay, so it's, let's say, the application, or let's say somewhere, okay? So something that the user has, it's not the device. As somebody said really well, we can change the device and still connect. Okay, so it's not the device. It's not authenticating the device. 802.11i is extensible to other CyberSuites and authenticated key management methods. This is something that maybe we were not discussing. So if you didn't read more about it, maybe it's difficult to know it like this. It is true. So it is possible to even use other authentication methods or other CyberSuites. So it can be, let's say, a negotiation between the parties on what they will later on use, except the ones that we talked about by now. WPA2 does not provide reply protection at all. What is reply protection first?
Replay protection is protection against someone sending the same message again.
Yes. So we can either, I don't know, sniff it and then reuse it. Either we start several sessions in the same time and then we reuse what we got from one session in another session or so on. So we reuse a message that was sent before. Is WPA2 providing replay protection in any way? Or WPA2 does not provide replay protection at all? Is true or false? Or it has a way of a mechanism to give some.
It's false because we use nonces and we generate keys for each connection.
Yes, that's true. And even something else that usually it's good for avoiding reply, because that we can say, okay, it's coming from some time afterwards. And then I can reuse encrypted messages in the same session later on, maybe.
It has a sequence number.
It has a sequence number. Yeah, it has a counter here. Very good. Okay, so this is false because it does at some point. Message integrity is a goal of WPA2.
It's true because it has a MIC.
Yes, it's true because it has this MIC here. Okay, that's correct. 802.11i protects all types of frames.
False. It does not protect the authentication frames, the first frames.
This is correct. It does not protect everything. Usually when we say, when we refer to frames, we also refer to them after at least the first initial handshake or so on, because otherwise we can say, okay, but the beacons that are sent, you saw, for example, in the capture for the lab, they're all the time sending clear almost, no? I'm not encrypting those. So like this in any protocol, there would be something not protected. But what is not protected here, and we will see it is in WPA3 that we will talk about today. We did not talk about that, are the management frames. So it's a special type of frames. We don't enter, let's say, in the networking part, but that we're not protected by now, until now. So this is also false. In 802.1x, authentication is done centrally at the server.
True.
This is true. And we finish. Yeah, why it's done centrally at the server? It's because, as we know from here, where was it here? Everything needs to go to this authentication server. So even if we have several APs, right, they're all talking to one authentication server that stores all these credentials for the users and so on. And then based on this, it provides authentication or not. Okay, good. So these were just the two activities. I will leave them on so you can. I also made this available now. I will not put extra points for people that do it. But if you want to, I don't know, you didn't do them now, or you want to review or something like this, you can see them now until the end of the semester. What we do? We continue without the break, like always, or it's somebody that needs a break. Nobody's saying anything, so I suppose we continue like always without the break. Okay. What I want us to talk about today, so that we kind of finish the Wi-Fi part, is WPA3. We talked about web, WPA, WPA2. Now it's time for WPA3. So WPA3, it's the best that we have at the moment. Okay. It brings some advantages over WPA, WPA2. But it's also, again, not fully secure. And it has been discovered, there have been discovered some vulnerabilities. One of them being the Dragonblood attack in 2019, so just 2 years ago. But it also brings some very nice things on top of WPA and WPA2. And in order to understand this, we will go a little bit back to WPA, WPA2 to see what was wrong there. And then we come back and we see why this is not working here. If you remember, in WPA2, we had this four-way handshake. And here I want to come back to something that somebody asked, Bogdan asked at the lab. He came with a very interesting thing. I don't know, many of you maybe did not do the second lab yet. But based on the version of the Wireshark you have, so Bogdan, the problem there was the version of the Wireshark. So after I also updated, I also got decrypted the key, the group key in the third message. So it's something that they added up afterwards in Wireshark, like a functionality. And depending on the version that you're using, you might see it or not. What I'm referring to, I was referring to this third message here. That in the capture that you will look at the laboratory, you will see something that here is sent even the group key. So instead of having a fifth and sixth messages that are independent after the four-way handshake, in the third message, the AP is also sending encrypted the GTK. It's not all the message that is encrypted. In that case, it's only the GTK that is encrypted. And this is what you're going to see in the capture. And the thing is that probably, okay, if you need to resend the group key many times afterwards because the key will be refreshed, or there are more keys. I was telling you last time about there is this key ID. So there are more sets of group keys. Of course, after some time, you will need the message 5 and message 6. But it seems that it can also be sent in message 3 so that we make a little bit of efficiency, let's say. And of course, it's encrypted because we already have the PTK, so it can be encrypted like it was encrypted even here. Okay. So again, for the ones that are seeing or not seeing this is something that is based on the Wireshark. What was happening here? There were the two nonces that were sent, and based on these two nonces and the MAC addresses, there was this PTK computed. And one of the problems here was that if the PMK was derived from a weak password, let's say in the personal edition, that means that somebody could have just tried a brute force or a dictionary attack. And we talked about last time, because the nonces can be sniffed in the four-way handshake, and the MAC addresses are also public. So whatever the adversary has to do is try all the possible PMKs, which are not so many if they come from a weak password. And then it gets more possibilities for the PTK, and it's just trying in this four-way handshake here or later on to see, okay, the MIG, for example, are they the same for each of the keys that I got? Whenever it's finding a match, it says, okay, this is the correct key. Okay. And this is a problem because it allows offline attacks. Okay. So basically, the adversary can just sniff the nonces, get the MAC addresses, or just, let's say, capture one of these four-way handshake, and then it can do an offline attack. It doesn't need to stay online and listen all the time and so on to get the PMK. And if it's getting the PMK, the same PMK will be used over and over again. So it's basically something that it affects the security of the network quite bad. So what WPA3 comes with, and that's the main, let's say, advantage of WPA3, is that it prevents this kind of offline dictionary attacks. So basically, even if the password is weak, and then from this password we derive a master key, the master key is not susceptible to an offline dictionary attack. And how is this done? It's done by something that is called SAE, simultaneous authentication of equals. And that was not a new idea for WPA3. Was appeared some time before, but not in Wi-Fi. And that was adopted in Wi-Fi using this, what is called the Dragonfly key exchange. And this is basically negotiation, let's say, between the station and the access point, starting from a password. So again, we talk about the personal edition, because again we have personal enterprise, and we will see there's something else. And at the end, starting from this password, even if this password is quite weak, they will end up with this PMK that is more secured, let's say, because it does not allow this type of offline attacks. And how is this done? Basically, this SAE, it's again a change of messages. It's like a handshake that has two phases, a commit phase and a confirm phase. And basically what happens is that in the commit phase, they both commit to a same key. And after the confirm phase, they both confirm that they have the key, this master key. So it's kind of something similar to what we had here, but remember that this happens before, because we need to have the PMK where we start, and the four-way handshake remains afterwards. The only thing that happens is, like, even if I have this four-way handshake and I still can get the nonces and I still can get the MAC addresses, I cannot derive the password. I cannot derive the PMK from the password, even if the password is weak. And how this works, now I don't know how many of you really have some more, some stronger notions of crypto. Maybe for some I will just speak Chinese at the moment, but I'll try just to have an idea how it works. So basically EC is coming from elliptic curves. Okay, so it's it can work on elliptic curves, it can work on something else, but let's say we have some parameters that the access point and the station set up. And then we have this password that is somehow encoded on one point on this elliptic curve. So think about elliptic curves as some points discrete somewhere in the space. And then what is happening is that both the station and the access points are selecting some random numbers. So whenever you see this arrow here with an R on top, it means that randomly selects from, I didn't put where, but from some space. So the station gets two numbers, an R and an M, and the access point gets the same. And then they're computing two other values, an S and an E. And how they are computing in this parameters, in these settings that they agreed before. So on elliptic curves, so for the ones that know elliptic curves, it's basically P added to P M station times. And then we take the inverse. And for S, here is just an addition modulo some Q, where Q is also in relation, let's say, with the elliptic curve. And then what's happening? So basically what you can see here is that both the station and the access point are generating some numbers. So they just generate randomly two numbers, and then they compute some numbers based on this, and this P, that P is somehow encoding the password. And they are committing to each other. Okay, so they're just sending these two values. And these two values are say that they are committing because then they're not changing the R or the M that they randomly select. So they are kind of committing on these values that they have. And then they're both computing the PMK as follows. So a key derivation function, that is a normal key derivation function. Again, we don't really care exactly the implementation, but it needs to be one way and all the properties that we said we need to have. And then basically the station is getting the S that it receives from the access point, this value. It multiplies the point so many times, so it's added up together the point with itself so many times as the S is saying, is adding this E, that it's another point on the elliptic curve. So here we will have a point on the elliptic curve. And then this point is again multiplied by itself, so added with itself so many times as the R station is saying. And the same is doing the access point. Okay, so it's doing the same computation. If we're doing the math here, we will see that they end up with the same PMK. Yes, because you can just I don't know, EAP here is minus MAP times P, and then the SAP was in fact RAP plus MAP. So this with this will go, and it will remain at the end the master key that is going to be this value here, the R of the station times the R of the AP times the point P. And the idea here is that basically these two numbers are randomly selected. So even if somebody is, let's say, trying or sniffing or whatever, there are two numbers that are randomly selected. They are not sent over the communication. They're just committing on top of them. So it's not something that they know. And they are used to hide the password. And this is how is derived the PMK. Okay. And then, okay, we have the confirm. Basically, it's a hash function. In fact, an HMAC that is computed on these numbers to check that both entities have the same value. And then it's starting, of course, the four-way handshake as before. So from here, after everything is confirmed, we can say, okay, they end up with the PMK. So from now on, they can start the four-way handshake. And here, we also have, of course, mutual authentication, because here in this commitment and then confirmation, it's also proof that the AP knows this password here, because if it doesn't know the password, then it cannot confirm. So it basically cannot compute even these ones, the S and the A correctly, and then it cannot compute the PMK correctly, and it cannot send the confirm message. So this see here. So this might be more technical details, let's say, that are not so much interesting for everybody. But the thing that you at least need to remain with is that this is something that prevents offline dictionary attacks. And this prevents those because it's basically hiding the password in a way that it also depends, let's say, on some numbers that can be all the time change differently and so on. So basically from here, the PMK will not all the time be the same, even if the password remains unchanged. So it will be all the time changed because it depends on these random numbers, okay, that are chosen. Okay. If you have any questions here. Okay, everybody silent, no question, you don't like this stuff. So we move forward. So this is something that is good for WPA3 and what WPA3 brought. The other very good thing about WPA3, it's a new way of thinking, let's say, with respect to two things. First, better crypto, so longer keys. That means better security. And that means so they basically introduced a new type, let's say, enterprise, but now with 198-bit mode. Until now, everything was 128 bits. Okay, so basically WPA3 also had 128. So when we talk about simple enterprise edition, we just speak about WPA3 enterprise with 128 bits. But they also had this more strong, let's say stronger security options where you can use 192 bits for the keys and so on. It comes with this management frame protection that we were talking, of course, just in the enterprise editions. And it's coming also with something that is very interesting, and that is unauthenticated data encryption. Do you know what unauthenticated data encryption can mean? What is providing? What's the goal?
Encrypting data from unauthenticated from users that are not yet authenticated.
Yes, that is really good. So it's basically I encrypt the data. So I want confidentiality, even for users that are not authenticated. And it might seem strange, right? But it is for open Wi-Fi networks. What is an open Wi-Fi network?
A Wi-Fi which doesn't require a password to enter.
Yes. So it's open for everybody, okay? So are you hearing me well? I got the message of bad quality of network. You confirm you hear me? Yes.
Yes, I hear you well, at least.
Okay, thanks. So open Wi-Fi means everybody can connect to the network. So I don't need the password to connect. So anybody can connect. Okay, it's let's say the Wi-Fi in a coffee shop or wherever. But after I connect, why all my communication needs to be in clear? Maybe I have the chance that somebody did not sniff my connection. Maybe. And maybe somebody did not was not impersonating me. Okay, so I can have a protocol between the client and the access point that after connection can allow me to set up a key a different key for every user based on some nonces that each is choosing and so on. And after that, I can encrypt the communication. So, okay, I'm not proving that I'm allowed to get to the network because anyway I am. I'm not proving who I am. I might pretend to be somebody else. But once I'm in, because you don't care in fact who I am because it's open, you give me this possibility of encrypting the communication. So it makes it difficult, let's say, for others to sniff and decrypt my communication. Okay, so even at the first sight might seem okay, it's a little bit strange. It's not. I mean, it's something that it brings me something. It brings me confidentiality after I set up the network. Okay. So these are basically the three things that I see important as a principle in WPA3 rather than whatever was before. The thing that I cannot have, I mean, I prevent the offline attacks. The thing that I can encrypt the data even in open Wi-Fi, and the thing that I can get better crypto, so better keys, larger keys, so better security. This is kind of what is about WPA3. I will add. I will show you now, in fact, but we will not stay on this. 2 seconds to put them. Some more things, if you want to read about, I will also put them there on the weekly info. Seconds just to take them. One, of course, is the Dragon Blood. If you want to read more about the Dragon Blood attack and why it is WPA3 not secure in general. Okay, and it's the same. One of the authors is the same as a crack for WPA2. And again, here you'll see the site is the same, and you will also see all the details, and you'll see the paper and so on. So it's basically what or very similar to what we already had for WPA2. And then there are some short videos that I will also add there online. We will not see now, but I encourage you can see them afterwards. One is from Real World Crypto. Real World Crypto is one of the let's say most famous conferences in cryptology for the real world, like the name is saying, Real World Crypto. So basically it's applied cryptography in the real world. And here is exactly the presentation of WPA3 and the Dragon Blood attack against WPA3. So you can also check this one. And then there is another interesting video again. If you, that is only a few minutes, not much. Where at some point it's also a discussion with him. So him being now you may notice the same author of the attacks that is explaining, okay, what is better in WPA3 rather than WPA2, WPA. And that's still okay. There are even some vulnerabilities and some problems here. Okay, so it's mostly talking about improvements, but also about the timing attacks, so the Dragon Blood in more very high level, let's say. I encourage you to see both of these, so I will put them in the lecture there for the for what we discussed today. Okay. Now, if you have questions. About WPA3, I don't know. Maybe there's another one that I want you to show, and something that you need to know maybe in general. I will put it now. And that's something not necessarily WPA3, but Wi-Fi security in general. When we talk about Wi-Fi security, where should we look at in general? We should look at the ones that did the specification, or let's say the implementation, no? So we need to have a look at the Wi-Fi org. Okay, so the Wi-Fi Alliance. I will now put it here, and then you will find all these links online. Okay. So this one, because then the thing is that, okay, you're finishing the master, you don't go to classes anymore. Things are changing in time, but you need to know where to take the information that you need from. And the best place to usually take the information are these big agencies or organizations, no, that are writing the standards or are putting a lot of white papers online that are easier to read and so on. So you have here in the Wi-Fi a section in the Wi-Fi Alliance for Security, where it's of course mostly, let's say, focused on WPA3 in the text, because this is what is now considered to be the most secure and so on. It's also written about this open Wi-Fi network that I was telling you, and that is nice. And then you have some resources here, and some of them are quite interesting. Some are not possible to open. You will see it register and so on, and ask for them. But some are possible to open, and you can read them. So, for example, here I went on WPA3 specification. Okay, so if you want to know much more about how WPA3 works, about how is, I don't know, this simultaneous authentication of equals working, how WPA3 enterprise versus personal works, or so on, you have here all the information that you require, okay, with all the details and so on. And sometimes are like these more technical, but sometimes are even, let's say, more easier to read or to understand, or okay, like this one, for example, Wi-Fi protected access security for Wi-Fi networks. Okay, and they explain why it is easy to use, what is I don't know, why it's fine now even to choose passwords that are simpler because of this, as I was saying, the Dragonfly Exchange and the SAA and so on. So and some security tips or so on. So keep in mind that all the time that you need something afterwards, I don't know, it's good to go to the source, let's say like this, and check whatever is there. Probably most of you were already knowing about the Wi-Fi Alliance, and where you can find all this kind of information. But it's good for everybody to know and have a look here. If you have any questions or comments. No.
I would have a question.
Yes, please.
What about routers themselves? Do they have vulnerabilities and exploits? I mean, it's still a device with software embedded in it.
Yes, everything has vulnerabilities. So I don't think it's anyone that can say, oh, my device does not have a vulnerability, or yes. In the software, as you're saying, there might be, and there are a lot of fixes, and yeah, there are.
Yeah, so for the Wi-Fi, we know we always choose VPA3, it's good and everything, but when we choose a router, do we look at the software or things like that?
Yeah, that's a very good point. Usually what's happening, it's the devices are certified. So the Wi-Fi Alliance is certifying devices. And if they are certified, they need to comply with some things. Okay. But of course, I don't think there's anybody anywhere that can, I don't know, that can certify that there's no bug or no error or in a piece of software or hardware, as you say, in the routers and the software that's running on top and so on. So even if the software is open source, and maybe even this year I will leave the lab. Up to last year we had it, a lab that I got online, so it was not mine, about the Heartbleed attack that you might have heard in the OpenSSL and so on. So there are libraries that are really famous and they are used everywhere, and they are open source and anyone can look into them, and they are still prone to attacks and trapdoors and things that people might realize after years and years that something bad happened there. So of course it's all the time a risk. But the thing that we can do all the time is just look at these kind of security tips or recommendations, and if you're up to date with this, you might try to keep as much up to date with your network or your system, whatever it is, because these kind of associations or organization or whatever, they are usually giving this thing. So this recommendation, don't use this anymore because this is not okay, use this one instead, because it's not 100% secure, but it's helping, no? Like here, I don't know, but it's of course it's something that it's yeah, you cannot have so for example, even this one, the removing of TKIP, which of course they are considered to be not okay anymore. Okay, and they are saying here, so this is a technical note. Okay, and then they say the problems encountered with using TKIP, which should not be, and these changes to this Wi-Fi certified that I was telling, and it is to discourage the use of TKIP WPA. Okay, because it's not anymore good. So please go to encourage the industry-wide transition to WPA2. But what's usually happening is that you need a lot of time, many years, to pass from something to something else. I mean, worldwide or nationwide or so on. So yeah, these things are all the time remaining. This the Wi-Fi Alliance is one. I think I've told you before. For us in Europe, for example, is the ENISA. that is also really good and is giving these types of recommendations and all these kind of things. So it's also really good to have a look here if you need something specific. Okay, because they also put out this kind of technical papers or recommendations or good practices or I don't know what happened good, what happened bad in the community or in the security world. Okay.
Okay, thank you.
Good. Any other questions? If not, we have a few minutes left and I want to do something else. I put something online. So we don't need this anymore. Also here in the Moodle, in the exam section, you will see 2 exams from the previous years, just to see, okay, how was looking the exam before. Again, I'm really sorry. The one 2 years ago, in fact, not 2 years ago, 1 year ago, because we switched to courses. So normally this would have been second semester, but we switched on the first semester. And the one from the last academic year, let's say, that was second semester, so now in spring, you can find them here. And one, I'm really sorry, it's Romanian only, but you can just translate it with Google Translate or whatever. The second one is English. It will be something very similar for you as well. What I did in the last years, and I will do the same this year, if we will have online exams, is that you will have 24 hours to submit the exams. So you will get the subjects, the exercises. You will have 24 hours to think about them and to submit them in Moodle. And you can submit as many times as you want, so don't leave it in the last moment. And after that, you will get the grade from the written exam, and you will have a meeting with me, not one-to-one, because now we need witnesses, where you answer some questions so that you prove you were the one solving the exam. Of course, there's also a risk. You can just do the exam together with the colleagues or somebody else solve for you or so on. But in the end, even in the real life, this happens. So when you're at work, you're not like working by yourself. You can ask a colleague, you can ask the support team, you can. So in the end, important is to solve the problem and understand it so that you can solve it again if it appears again, right? So that's the idea of the exam as well. And how is the exam structured? Basically, there is a true or false section at the beginning. And then there are 2 more detailed, let's say, exercises, where it depends about different things that we were talking during the course. And I wanted to, I put them here and I want to bring them to discussion because I want to go over them together so that we discuss them and see how it was and how, I mean, it will be similar even for next for the next exam. What I didn't do, but I think it was not the case. I think nobody registered for today. No. Remember to register with the presentations because for both the course and the lab. And what I want to ask you now is for next time to have a look at the exercises that are related to what we did by now. So the Wi-Fi. For example, in the last exam, you can have a look at exercise 2, which is WPA2 security, and we can discuss it next time. Okay. So basically you get a scenario and you need to answer some questions. This is something we did not discuss yet. So, and this we will discuss now together. And the same here in the second one, So this is something we did not discuss yet, but this is something we discussed even now. So basically, this is the one that you don't like so much. So it's the mathematical thing. And that's another thing that you have to expect in the exam. So don't expect to be something that we definitely discussed. It can be even something that you are supposed to understand by searching something or doing a little bit of research or things like that. So for example, in here, in the last year's exam, it was something like, okay, we're talking about the crack attack and consequences it might have in the network in terms of, and it's a specific vulnerability. So I expect you to know how to go online and search, okay, this is what is CVE 2017-13080. Oh, it's this specific type of vulnerability. Okay, I need to choose a specific vendor and I need to check, okay, respectively to my choice. Is this still available? It is not. It happened. It didn't happen. It was affecting this device or not. So this might be something that is happening to you if you will work like a, I don't know, network engineer, let's say, a security engineer. No, it's like, okay, I get the problem. I don't know what it is because I cannot know everything, but I need to search for it. I need to see what's about. I need to see, okay, my devices are prone to this or are not prone, or what can I do to solve it? Okay, but of course you have, you're allowed to use whatever. You can use the internet, you can use sources, you can use, so you have basically one day to solve these problems, okay? You don't need so much. So basically the exam, it can be solved in 2 hours or 3 hours, not more, okay? If you have other questions regarding the, I don't know, structure or like this of the exam, now that we started to talk about this one. No, if not, because we have some more, let's say some time, a little bit of more time, a little bit of time, I would like to start talking about these ones that are quite easy, and I will start with the ones in Romanian because I can translate them to English. So if there are people that are not understanding Romanian, they can just hear me translating. So what we care, it's true or it's false. So WPA and WPA2 enterprise, in WPA2 enterprise, there is one single common password for all the users. Is this true or is this false?
False.
False. Okay. And then you need to change this one with a minimal, I mean, change it minimally, but not putting a not. You cannot say, yeah, in WPA2 enterprise, it is not a single common password. How can you do it to be correct? There are more possibilities here. You can choose whatever it's better for you.
In the personal case, it does use one common shared password, but in the enterprise, there's authentication done for each user that tries to connect to the network.
Perfect. So we can easily change it by, for example, changing here enterprise to personal, and we're done. Okay, perfect. B, a system is giving, let's say, integrity protection by using a CRC, a cyclic redundancy check. Oh, is this correct? Or let me take it. Or is this incorrect?
It's false.
It's false. Okay, why? How can we make it be nice?
We need to use a key to protect the hash message of the that we authenticate maybe the data or so. So without a key, we cannot prove that, or someone can to say go and calculate the CRC.
Okay, that's perfect. So how can I change it? I can say instead of CRC, I can put the MIC, message integrity code,
Yes. Yeah.
let's say. Okay, which of course has a key. If you feel the need to write more details, you can write them. Okay, if not, it's not necessarily requested. But it's like you will end up a PDF, so you can write whatever you want there. Anyway, we will discuss in the online setting in the meeting.
I have a quick question here.
Please.
So if we provide, let's say we have two sentences as the answer, and the first sentence is enough to count as a correct answer, but then there's something wrong in the second, do we get minus points?
If you put two, nah, I usually don't do that. I mean, if it's something that is really bad, yes. That is something that is really, I don't know. If you say afterwards that the CRC is used to to assure confidentiality, yes, you might get some minus points there. But if you say something that's not so bad, no. Usually I'm pro student, I'm not against the student. Yeah.
Okay, thank you.
Okay, the third one. One of the very important problems of web concerning confidentiality and for which it should not be used is the complexity of the computation.
It's false because it's just using to say on a string cipher, and that is not the complexity. It's lower compared to the
Yes.
block cipher used in the web, for example.
This is correct. I mean, web there's a XOR there, in fact, and an RC4, and that's not the problem because, I mean, confidentiality, okay, you might say anyway, if it's really complex, it might be a problem because it's not effective, because it's taking time, because it's slow and so on, but not necessarily impacting confidentiality. No, I mean, if I have a cipher that is very, very slow, I don't want to use it, but it might be really, really good. I don't know. But also what you said, no, it's not that because anyway, web is quite fast. So for encryption. Okay, in TKI, yes, please.
Sorry. Quick question about the source of the to say exam. Will you publish as a PDF or will you publish the source to say if it's a markdown or it's an
No, the PDF.
The PDF, okay.
Yeah, so this is in LaTeX, but it doesn't matter. So you'll get exactly like here, the PDF.
Yeah, I thought that you will get the source. It will be sometimes it's more easier to say to go and reuse to say the source, the plain source, instead to say going to and copy from the PDF. But anyway,
but
okay.
you don't need okay. But you don't need to. I mean, here you can just copy paste from here. It's not, and you can write as you want. So the only thing for me is to end up a PDF. But if you want to write by hand, take a picture and upload it. It's fine for me. Just take care to write so that I can understand. Okay. Of course, I prefer something written in Word, in LaTeX, in whatever editor, so that it's easier to understand. But you can also write by hand. So it's I don't care. In the end, it needs to arrive to me a PDF via Moodle with the solution. Again, all this, it's happening if it will be in online settings. We don't know yet how the exam will be. But as things move, I tend to believe it's going to be online, the exam as well. Okay, just to finish, because we only have this one and then we're done. In TKIP, the pairwise keys are used for one-to-one communication and the group keys are used for the broadcast communication.
It's true.
It's true. Okay, and the others we're not discussing here because we did not talk about that yet. Okay, And the last ones, okay, not even, because they were from the project of the students. And now what we will do next time, we will do the same for whatever we can discuss here from the other exam, plus if you can have a look at the exercises to talk even about that, so that you have some examples about. Again, it's not something that's black and white, so most of the questions you will see there are some discussions. If you have some time to go over them, that would be great. If not, we will discuss them anyway next time. So it's not a big deal. If you have any other questions, comments, or
Yes, I would.
Here in the sorry.
You can go first.
In the VP3, the exchange protocol looks like the Diffie-Hellman key exchange protocol, but in your slide I saw that his name is the Dragonfly protocol or something.
Yes, it's not really the Diffie-Hellman.
Okay.
It's kind of looking, let's say, like Diffie-Hellman, but in Diffie-Hellman we only had one of these. Let's say just the heirs. And then when we were submitting, let's say this one times the value of the number of the point.
And one more question about: is there any tentative date for the final exam, or I'm just wondering if it's now when it will be scheduled the exam?
You know that there is the calendar on the
yeah, I have to check. Yeah. Okay.
Okay, so if you go, I check here, but there are the academic calendar. Sorry, not in English again. You will not find, you find it, but you can translate maybe. And this is the one from the faculty. And here you should find the exact date, let's say, for the exam sessions. So basically, we will have holiday just from the Christmas Eve to the 3rd. And then we will have 2 other weeks, and then we start the exams. And most probably the exam for network security will be quite early in the exam session. I will ask you to put it quite early in the exam session.
So how will you advertise to say the final exam in Teams or in Moodle?
In Moodle.
Okay.
So what will happen? It will happen that here in Moodle, in exactly this exam section, you will find the exam for this year. Okay, I'll put it maybe bigger, something like this. I can show how it was last year. This one. Okay, so here was the last year exam, the exam submission, and the exam questions. So basically, the exam questions is where you get the PDF. It's just what I showed you now, because you don't have access here. And then in the exam submission, you can submit the exam. You can upload the file.
In the worst case scenario, to say if somehow due to say that personal, I don't know, reason, I cannot to say submit that period. Is it possible to say is there any re-examination period or something like that?
Yes. There are here some re-examination. I would really not advise you to do that, because I mean, I don't know, it's up to you, but it's only one reason you might not do it with me. You might do it with a colleague, and every time that the professor is changing, you might have some, I don't know, changes. But the examinations, so there will be re-examinations here for the first semester. So there will be in April. So you will have one chance in April. And then you will have another chance in May.
Thank you.
Are these ones for the first semester. And then for the second semester, no, wait a little bit, because I'm looking really bad, because I'm looking for the final year, your master first year. So you will have them directly in May, or the second time in September. Okay, is this one. I'm always used to the second year of master, the third year of bachelor. Sorry. Okay, so you can check here. So basically you have two possibilities during the year. If you don't do that, you can retake next year. Even we have some students that did not graduate last year and they need to redo the whole course. So if you don't manage in 3 times, you need to redo the course. And another thing, take care because I think you pay. So the first 2, this is something you need to ask the administration, but I think the first 2 chances are for free. And when you come to the exam, so you submit the exam. And the third one, I think starting from the third, you need to pay some tax or something. But that's something that the administration can tell you. Okay, any other questions? Okay, thank you too. If there are some other questions, because I didn't give you a break and we're already late. So people will be upset with me because I'm keeping you after the hours.
Yes, I just had a quick question. So is it possible that in the exam we will have questions that are from the presentation of lab projects from us?
Lab projects, no, because you're not supposed to come for our lab classes. The lab is every 2 weeks. So some of you will, of course, at least, let's say approximately half of the labs you will miss of the presentation of the projects, okay? From the course project, there might be. Okay, so whatever you found, for example, here, where was it? This one, or even these ones, because we were talking about this. These 3 are from course projects. We had a different type of project last year and so on. I'm changing all the time, that's why. So this maybe will not be for you, but you might have questions, even more like this from the course projects. But again, not something that, I mean, something more to think rather than learn something, mostly because anyway, you will have all the information with you. You can read whatever books online.
Okay, that was my question. Thank you.
Okay, you're welcome. So thanks for attending, everybody, and see you this Friday for the ones that want to join the lab, or next week